So this paper had 11 questions, okay? And according to the instructions, we have to answer all of them. Answers only will not guarantee full marks, okay? We can use a calculator, round off to decimal places. Diagrams are not necessarily to scale. No pages may be torn, okay? We're not gonna do that. Answers must be written in black or blue ink, okay? Indicate questions you've answered by drawing the cell. No, we're not gonna do. We're gonna answer everything, okay? Draw a neat line through any work that must not be marked. All right, so those were the instructions. Let's just dive into the paper. All right, so question number 1, they're telling us that the histogram below shows the marks in percentage for the grade 11 learners in their November 2024 examination. Okay, so the minimum mark is 10, or we're looking at the minimum or the lower class interval is a 10. Then 20, so between 10 and 20, we have 2 learners. Between 20 and 30, we have 3 learners, and so on and so forth. So meaning that the highest mark that could possibly have been achieved was 80%, okay? Then they want us to complete the table below. So this table is showing us the frequency as well as the cumulative frequency. So let's start with the frequency. So we have a 2, okay? Then we have a 3, and then we have a 4, and then we have 6, 5, 4. It's a 6, 5, 4, and a 6. Then for us to get the cumulative, we know that the first cumulative should be the same as the first frequency, which is a 2. And then we plus 2 plus 3 is a 5. Then 5 plus 4 is going to give me a 9. Then 9 plus 6 is 15. 15 and 5 is 20. That's a 24. Then that is a 30. So the total of the frequencies here, we must get 30. That must align with the last cumulative. All right, so those are the sweet 2 marks that we have there. Then we move on. They want us to draw the ogive or the cumulative frequency graph. Okay, so we have the intervals already indicated and everything. So the only thing I need to do is extract my cumulative. So we have 259. Okay, we're saying 259. Then we have 15, 20, 24, 30. Okay, 24 and a 30. Okay, so when you're plotting the cumulatives, we always use the upper intervals, meaning that we're going to use these numbers, the 20 and so on and so forth, and then we shall end up with a 10. So 20 is going to go with a 2. Okay, this is 2. And then next we have 5. So 30 is a 5. And then our 40 is going to be a 9. 9 is just below 10. And then 50 is going to be 15 just on the line. And then 60 is going to be 20. And then 70 is going to be a 24. Okay. And then 80 is going to be a 30. Does that make sense? It's going to be a 30. Somewhere there. Okay, so that is what we have according to our points. Then just connect those points with your free hand. Okay, I'll try to be as accurate as possible, but in as much as it may not really be possible. Okay, we have something like that. And then we have to foot this graph to the origin, which is the 10. So where's our 0? This is our 0 and the 10. So meaning that the graph must start from 0 and 10. All right, so that is our cumulative graph that the question wanted, and as much as it is not looking more of an S, but it's fine. Then 1.3, use the ogive to estimate how many learners obtain at least 54%. So the word at least, it simply means the minimum is a 54%. So we can have even more than 54%. So let's go to the marks, okay? So with the marks, we have 50. This is 52, this is 54, 56, 58, and then 60. So we're gonna follow this line of 54 up until it meets the graph. Let's use which color? Let's use purple. So 54, draw the line, okay. when I look at my ogive, it's meeting at this point here. Okay, and then I'm gonna read off this value. Okay, this value is I'm getting a 17 according to my graph. You could have gotten something that is close to that. Okay, so we have 17 learners that have less than 54. But now for us to get more than 54, we're gonna get the maximum. Okay, whatever is above here is more than 54. So you're gonna say 30 minus 17. Okay, 30 minus 17, that must give us something like 13. Okay, so we have 13 learners. Okay, so 13 learners have just above 54%. All right, then we move on to the next one. It is further given, okay, that the minimum mark is 12 and the range is 66. Use the grid provided to draw a box and whisker. So for us to get our box and whisker, remember box and whisker is a summary of the 5 numbers. Which 5 numbers must be the minimum? The Q1, the Q2, the Q3, as well as the maximum. But the question told us that the minimum is a 12. And then we need to get we were given the range. So we know range is maximum minus minimum, meaning that for us to get the maximum, we shall get our range plus the minimum. So if we get a 12 plus a 6, no, plus a 12. Oh, we're saying 12 plus 66, okay? So the range is 66 plus 12, which gives us 78%. So maximum is 78%. Okay, then we need to go get the Q1. So we're going to start by finding the positions, okay? So for us to get the Q1, we know that the position is going to be a quarter of n plus 1 or just a quarter of n, okay, whichever you want to do it. So what is a quarter of 30? Because our maximum is 30. So 30 divided by 2 is giving me 7,5. Okay. It's giving me 7,5. Let's see. Okay, 7,5, 7,75. Okay. So this is the position of Q1. Okay. Then for me to get my Q2, I will say a half of n plus 1 or a half of n. Okay, which is like 15. This is the position. And then for me to get my Q3, I will say 3/4 of n plus 1 or 3/4 of n. So 3/4 of n, I'm getting 22,5 as the position. Okay. If you say 31, then it's going to be 23, something. Okay. So let's see. So if I use a quarter of n, why don't I use n plus 1? No, either way. Okay. So let's say our position is 7,5. Where do we find 7,5? This is a 6, a 7, and 7,5 is somewhere here. Then draw the line up until it meets the ogive, and then we read off the mark. So we can see that the mark is somewhere here before 14. Okay, so this is going to be 38. So our Q1 is a 38. Let me jot it down here. Okay, 38%. Then I need to go look for the Q2. We say the position is 15. So when I look at the 15, from our graph, we saw already that the 15 is aligning with the 50. Okay, so meaning that our Q2 is going to be a 50%. And then to get the Q3, we say the position is 22,5, or you can easily round it off to a 23. Okay, so 22, now this is 21, 22. Okay, meaning that it is somewhere here in the middle. Okay, in the middle, and then we're getting it somewhere here, and then we drop it down. So if I drop it down, I'm getting an answer between 60 and 70. So this 60, 62, 64, this is 66. Okay, so remember all these are just estimates of how we would have done this. So that's the 66%. Okay, so we just need to represent these numbers on the box and whisker. So 12 is the minimum. So 10, this is going to be our 12. And then 38, this is 30, is going to be somewhere here. Q2 is 50, somewhere here on the line of 50. And then 66 is going to be somewhere here. And then our maximum is 78, which is somewhere there. So draw your box with your ruler. Okay, we have something like that. And then connect the whiskers. Okay, so we have our box and whisker in that format. Okay, so that is question number 1. Question number 2, we're dealing with the bivariant data. Okay, so we're given that the town manager conducted a survey to measure the pressure of the sea level in his coastal city. The table and the scatter plot show the results of the survey. Good. Then they want us to determine the equation of the least square regression line. So remember how to use the calculator when you're punching in all these values. So remember the first variable will represent the x, and then the second variable will represent the y. But even the graph tells it all, that the pressure is on the y-axis and then the depth is on the x. So when I punch all of this into my calculator, and we know that the equation of the least square is given as a plus bx. Some people write it as bx plus a, no problem. So my a that I'm having is a 55,96 plus my b is a 22,81. Okay, so that is our equation. We'll get a mark for the a, for the b, and then rewriting it in the equation format. All right, then use the scatter plot to draw the line of least square regression. Okay, so for us to draw the least square regression line, remember, sometimes we call it the line of best fit. So we have 55,96. So this 55,96 is like the y-intercept. So if this is 100, then 50 is going to be somewhere here. And then 55 maybe slightly somewhere there. Okay, then we need one other point, and the point that we need is the mean of the x values and then the mean of the y values. Okay, so if we can get this center point, and I'm having 17,8 as well as 462. So where is 17,8? This is 16, 17, 18. Okay, so somewhere here in the middle. Okay, so in that middle, we need 462. So 400, 420, 440, 460. Okay, so meaning that our point is somewhere there. Then just draw a line to connect just these two dots. Okay, if you can draw your line, I'm sorry, I don't have a ruler, but I'm just trying my best. So you'd have something like that. So that should be your line of best fit or your line of regression. So passing through the mean of x and y, and then passing through the y-intercept. So that is your line of best fit. Then write down the correlation coefficient. So my R that I'm getting is 0.95 something. When I round it off, I'm getting 0.96. Okay. And then 2.2, okay. Research was conducted to measure the testosterone in runners at the Olympic Games. The table below shows the 5 numbers or the 5 runners who were tested for that thing. And then the mean of the 5 numbers is 7,7, and then the values of the last 3 form an arithmetic Marawai. Can this examine? Well, this was paper 1. Now they are still haunting us with paper 2 things. It's not fair. All right, so they want us to get the values of K and P. Anyway, at least Pythagoras is not meeting with Shakespeare here, but at least the examiner is trying to haunt us. Okay, so what I'm gonna do, let me start by looking at the last 3 numbers. So P, 3,8 and then 4,3. So for us to have an arithmetic, the common difference needs to be the same. So 3,8 minus P, and then we know that 4,3 minus 3,8, I'll get 0,5, okay? So these two must be equated to each other. So 0,5 is the same as 3,8 minus P. let's transpose, meaning that P is going to be a 3,8 minus a 0,5, which gives me a 3,3. That's our P value. Okay, then let me bring in the aspect of the mean. Note that the mean is the summation of all items over the number of items. Meaning that if I get my 6,7 plus my 2K plus 2,4 plus my P, which I got as 3,3, plus the 3,8 plus the 4,3. Okay, when I divide this by 5, okay, I must get a 7,7. Okay, so let me simplify my decimals and like terms. Okay, so this is a 2K, okay, plus when I add up all the other things, I'm getting a 20,5. Okay, this is going to be the same as 7,7. Then I'm multiplying it by 5 because I need to get rid of this denominator. So times 5 and then times 5. Okay, so I'll have to move the 20,5 that side. So it's going to be a 2K. It's going to be a 38,5 minus a 20,5. So 2K becomes 18. Divide both sides by 2. And then K becomes a 9. All right, so that is how we would have answered this. Ne? Then question number 3, which is the analytical geometry. We've been told that in the diagram, triangle ABO is drawn, okay? E is the midpoint of AB, which is produced to C, okay? A is the x-intercept, and C is a 0 and 10, which is the y-intercept. Line EF, okay, is parallel to the x-axis, so meaning that if this is a midpoint and these lines are parallel, which means even this one is a midpoint. Eh? Then AB is perpendicular to OB. Okay, we see that 90, perfect. The angle of inclination is 108,43, beautiful, indicated. Then the angle formed by AC and the y-axis is alpha. Then 3.1, they want us to get the gradient of AB. So we don't have any coordinates here on AB, but we have the angle of inclination. So we know that M is equal to the tan of theta. Okay, this is the formula for the gradient in case we don't have the coordinates, for as long as we have the angle of inclination. So it's going to be the tan of 108,43. And when I punch this into the calculator, remember it is tan, not the arctan. Okay, 43, that is giving me negative 3,000, so meaning that our gradient is a negative 3. Then 3.2, we must find the equation of AB. Okay, so what do we know about AB? We only have one point, which is the y-intercept, okay? And this y-intercept is at a 10. We don't know the gradient of this, but we have the gradient of BO, okay? So since the lines are perpendicular, we know that the gradient of AB multiplied by the gradient of OB, it should give us a negative 1. Now, since the gradient of OB is a 3, which is negative, we're going to say that MAB is going to be negative 1 over the gradient of OB, which is a negative 1 over negative 3, which becomes 1 over 3. Okay, so we have our gradient, and we already have the y-intercept, meaning that y is going to be 1 over 3x plus a 10. Okay, so that is what the question technically wanted. Show us this multiplication of perpendicular lines, and then the answer. All right, then calculate the coordinates of B. Coordinates of B, so we know that B is a point where the two graphs are meeting, or the two lines are intersecting. And at this point, the two lines are equal to each other, meaning that if we get the equation of, we said 1 over 3x plus 10, and then we need the equation of this, we got the gradient as a negative 3, okay? But the y-intercept is a what? Is a 0. So the equation of OB is simply going to be negative 3x. Then we solve these two simultaneously. So what I'm going to say, I'll say that the equation of AB equated to the equation of OB. So 1 over 3x plus 10 should give me negative 3x, since everything is y. Let me collect the like terms. I'm going to say 1 over 3x plus a 3x is equal to negative 10. When I do my magic here, I have 9x plus 1x, which is a 10x over 3, is equal to negative 10. Cancel the 10s. So it's like a third of x is negative 1, and then x becomes a negative 3. So if x is a negative 3, let's use the other equation of negative 3x to find the y. So it's a negative 3 times a negative 3, which becomes a 9, meaning that b is a negative 3 and 9. Okay, so that is how I would have gone about this to get the 3 marks. Then they want us to get the length of BF. Okay, the length of BF. So we say this is a negative 3 and 9. Length of BF, where's BF? So from here up to there. But we don't know the coordinates of F. So the quick way, since we are saying that F is a midpoint, né? Okay, so step number 1, we're gonna say that F is a midpoint of the side B what? BO. Reason being, we have the midpoint theorem. Okay, so then if that F is a midpoint, what I can do is I can simply calculate the distance of OB, and then I divide it by 2. So if my O is a 0, 0, and then my B is a negative 3 and 9, let me use the distance formula, which is going to be x1 minus x2 squared, and then y1 minus y2 squared. Okay, let's do the substitution. That's going to be 0 minus 3 squared plus 0 minus 9 squared. That's going to give me a 9 plus 81, which is the square root of 19. Okay, so if the square root of 90 is going to give me 3 square root of 10. So this is the distance OB. But BF is a half of OB, meaning that 1 over 2 times 3 root 10. So we get 3 over 2 square root of 10 units. So I would prefer to leave it like that and not necessarily put it into decimals. But for people that love decimals, if we were to use decimals, what would be the answer? It would be a 4,74. 4,74 units. Okay, so that is 3.4. Then 3.5, we want the area of CBO. Okay, I'll use this. The area of CBO. What do we notice? What do we notice? So we notice that this is a right-angled triangle. Okay. Now, what I can do, there are 2 ways to this. How many marks is this question? It's 4 marks. If B is negative 3 and 9, I have a quick way of doing it, but I'll try to check it with a longer way to see if we get the same answer. So the quick way is for me to focus on this right-angled triangle and create another 90 if this is a perpendicular. If this is my height and the whole of this is my base. Okay, meaning that our base is gonna be 10 units because from 0 up to here, that's basically 10 units. Then the distance from this line up to the B is going to be 3 units. Okay, distance is never negative, so that's 3 units. So meaning that our area is going to be a half times the OC, then multiplied by the perpendicular height. So a half times 10 multiplied by 3, which gives me 15 units squared. I feel this is the quickest. Okay. So alternatively, somebody could have said that it is a half, this being the base OB, and then the height being the BC. Okay. So if that is the case, we have the distance of OB. Okay. We got it as a 3 root 10. Okay, let me just, okay, 3 root 10. The only thing that is shorting is the distance of BC. So for us to get BC, 0 minus minus 3 is going to be a 3 squared plus 10 minus 9 is going to be a 1 squared. So that is a 3 squared, which is 9 plus 1, which is root of 10. Okay, so that is a root of 10. Then I have a half times 3 square root of 10 times the root of 10. Okay, what does this give us? So root of 10 and root of 10 gives us a 10. So it's going to be like 30 divided by 2. And that is 15 units squared again. So I'll take my approach to be the quickest. Okay, so that is that for 4 marks. The examiners are now generous. Eh? All right, 3.6. Let's find the alpha. Okay, they want us to get the size of alpha. Now, let me just erase this out so that we make more sense out of this. Okay, so for us to get the alpha, one thing I want us to do is we know that this is a 90. Okay, if that's a 90, because between the y and the x, we can find this angle here, which angle is BOC. Okay, then we know that this is also a 90 because these angles are just on a straight line. And then we can find this angle here, which angle should be vertically opposite. So we shall start with BOC. Okay, we're saying BOC is going to be 108,43 minus 90. 108,43 minus 90 gives me 18,43 degrees. Okay, then I know that my CBO is a 90 angles on a line, or some people will say adjacent supplementary angles, which is correct. And then BCO is going to be a 90 minus 18,43 because angles in a triangle must add up to 180. Okay, when I say 90 minus 18,43, that gives me a 71,57 degrees. And then we're going to say alpha is 71,57 because they are vertically opposite. So that is how I would have worked that out. Or if you have any other alternative of how to do that, we would gladly appreciate it. Okay, but then that is how I would have taken it. Okay, then that is the end of question number 3. Question number 4 with the circle geometry, no, the analytical geometry with circles. Okay, what are they telling us? We're being told that in the diagram, P is negative 3, 4, is the center of a circle that is passing through B, which is the x-intercept. And then T is the origin. And then a second circle Q is having this much of an equation. Points R and S lie on the circle. Okay. AS and AR are both tangents, so tangents from a common point must be always equal. B is the x-intercept, we saw that, of AS. All right. First things first, they want us to get the equation of P. What do we know about P? They told us this circle is passing through the origin, meaning that the distance between P and O is our radius. Okay, so we're going to say that our OP, okay, OP is going to be the square root of 0 minus minus 3 squared plus 0 minus 4 squared. This gives us a 5. Okay, so if that is the radius, we know that the general equation is x minus a squared, and then y minus b squared is equal to r squared. So our x is a negative, meaning we're going to switch the sign to a positive. So x plus 3 squared plus y minus 4 squared. When you square 5, we end up with a 25. So that is our equation for circle P. Then OT is a diameter. Okay. So if we connect this to that, that is our diameter. Perfect. So that's a 5 and that's a 5. They want us to determine the coordinates of T. Okay. So what we know about this P being the center and this being the end, for as long as the diameter, this becomes the midpoint. And we're going to use the midpoint formula. So if our O is 0, 0, our P is negative 3, 4, our T is XY. So we're going to say X plus a 0 over 2 must give us this midpoint negative 3. Cross multiply, X is a negative 6. Do the same with the Y. Y plus 0 over 2 should give us a 4. Cross multiply, Y is 8, meaning that T is going to be a negative 6 and 8. Okay, paper is still flowing, guys. Ne? Yes. Then 4.3, they want us to get the coordinates of Q. What do we know about Q? Q is another circle whose equation we know. Okay, so what we're going to do, we just have to complete the squares there. So it's x squared, okay, minus 12x plus y squared plus 12y plus 54 is equal to 0. That is the equation. Okay, then what I'm going to do, I'm going to move this 54 to that side because I prefer working with it on that other side. So it's going to be x squared minus 12x plus y squared plus 12y is equal to negative 54. Okay, so what I'm going to do, complete the squares, open your bracket, that is x. A half of this is negative 6. Okay, so negative 54, I'm just going to plus with a 6 squared. Okay, because I said a half of 6. And then plus, open the bracket for y, this is y. A half of this is going to be a positive 6 squared, and then I'll plus it that side. Okay, then meaning that we have x minus 6 squared, and then y plus 6 squared. When I simplify this side, I have a negative 54 plus a 36 plus 36, which is a 72. So 72 minus 54, I get 18. What did the question ask for? Coordinates of Q. Since Q is the center, Q is going to be a 6 and a negative 6. All right, so that is how I've gone about that. Then determine the equation of AS. What is AS? AS is a tangent, okay? For us to get the equation of the tangent, we need to start by getting the gradient of QS. All right, so our Q, we said it's a 6 and a negative 6. Is that correct? Okay, and then our S was a 3 and a negative 9. So let's get the gradient of that. So gradient of QS is going to be the change in Y over the change in X. So negative 9 minus 6 over 3 minus 6. This is a plus 6. Okay, from the top, I'll get a negative 3 over, this is going to be a negative 3. Does it make sense? And then I'll end up with a 1. Let's see the direction of that line. It's positive. Okay, perfect. So if that is 1, meaning that the gradient of AS is going to be a negative 1, since the gradient of 1 times the gradient of AS should give us a negative 1. The lines are perpendicular. Ne? Reason, we're going to say the turn perpendicular to the radius. All right, so we have our gradient. We can use the point S, which is 3 and negative 9. Okay, at 3 and negative 9, we can say y minus y1 is equal to m into x minus x1. So y minus 9 is equal to a negative 1 into x minus a 3. Let's open up That's going to be a negative x plus a 3. Let's move this one that side, meaning that our y is going to be a negative x minus a 6. So that is how I would have obtained those sweet 5 marks. Okay, so if I've left out something, please just slot it in the comment section and let's continue cruising. 4.5, identify the type of quadrilateral that ASQR and substantiate. Shakespeare is back. Substantiate. In other words, give a reason for your answer. Oh, so ASQR. Okay, so what I'm seeing is that with ASQR, one thing we say that this is a radius, this is also a radius. Okay, tangents from a common point are equal, meaning that this shape is definitely a kite. Reason, we have two pairs of adjacent sides that are equal. All right, so we're going to say the shape is a kite for 1 mark, and then for the substantiating, we are saying two pairs of adjacent sides. Adjacent simply means next to each other. Adjacent sides are equal. Okay, in other words, if you don't want to say that, then you can give the sides themselves. Someone would say AS is equal to AR, and then QR is equal to SQ. It's fine, no problem. All right, so that is 4.5, and then 4.6, determine the scale factor. Okay, determine the scale factor K by which the radius of the circle with Q should be increased such that the two circles must touch. Okay, scale factor with which the radius of the circle with Q must be increased so that the circles should touch. Now, which circle are we looking at? We're looking at Q. In other words, this Q must be increased. Okay, but we want to see by how many times. So if we increase it, the question never told us how many points, but they are telling us they must touch once. Okay, all right, that's perfect. So for it to touch once, okay, we're saying that for it to touch once, the distance OQ is what we're going to be looking at. Let's get our radius OQ and then compare it to the radius. If this is, let's say, I'll say QR. And then we see how many times. So since we say that O is 0, 0, and then Q, we said it was a 6 and negative 6. Let's get the distance, the radius OQ. So that's going to be x1 minus x2 squared plus y1 minus y2 squared. Okay, square root, that's going to be a 0 minus a 6 squared plus a 0 minus minus 6 squared. So that's going to be a 36 plus another 36 under square root, which gives us a 70 what? A 72. Now we know that square root of 72 is going to be, so we're saying R or Q is going to be 6 square root of 2, okay? Then initially, okay, the initial radius RT, I don't need to go there. Okay, the initial radius RQ, sorry. Remember it was something like 18. R squared is 18. From the equation that we worked out, where was the equation? Here is the equation, okay? R squared is 18. So I'm saying that my RQ is going to be the square root of 18. And square root of 18 gives me just 3 square root of 2. Okay, then let me try to divide these two. So 6 square root of 2 divided by 3 square root of 2. This cancels that, and then that is 2, meaning that the scale factor K is 2. So scale factor K is a 2. You must increase it by 2 times, and then we shall get what is desired. All right, so that is how sweet question 4 was. Question number 5, which is the trig. All right, let's start with this. They're telling us that the sine of beta is positive 12 over 13, where tan beta is less than 0, meaning that the tan is negative. The sine is positive. With the aid of a diagram without a calculator. Okay, so for 4 marks, they're going to give us 2 marks for the sketch first. Ne? So we know that sine is positive in the first quadrant and the second quadrant. But between the two quadrants where sine is positive, where is the tan negative? Definitely the second quadrant. So that is where our sketch should be. Okay, so let's indicate from our dear friend, so Kato, we know that the sine is the opposite over the hypotenuse. So this is a sweet 12 over the 13. Okay, so we can say this is our beta, no stress. And then we need to find the missing side. So use your Pythagoras. So if that is all, call this a P, call this a T, no stress. Tell us that our OT is going to be the square root of 13 squared minus 12 squared. That's going to give us a plus or minus 5. But the fact that OT is on the left-hand side of the Cartesian, so this is going to be a negative 5. So that's all you need. You probably have 1 mark for that and then 1 mark for the Pythagoras. Okay. Okay, so we move on. They want us to answer and find sine 2 beta. Okay, so this is the double angle of sine, which can be expanded as 2 sine of beta cos of beta. Okay, 2 times sine beta we were given. It's a 12 over 13. Cos of beta is going to be negative 5 over 13. So 12 and 2 is 24. 24 and 5 is going to be 120. 13 and 13 is 169. There's nothing common then. I want to believe so. Okay, 120 over 169, nothing common. Just leave it like that, please. I know temptation sometimes are strong, and then somebody will be convicted to change this to a decimal. That's how they're going to get you, that you use the calculator. So you leave your answer just the way it is here. All right, 5.2. Telling us that the compound formula for cos is given as that. They want us to use that identity to deduce the sine of alpha minus beta. Now, from our complementary angles, we know that if we have the cos of, let's say, 90 plus theta, this gives us a negative sine of theta, or 90 minus will give us a positive sine. So I'm going to use the 90 minus this complementary approach and then get to that. So this is going to be the cos, okay? I'll say 90 minus, we have alpha minus theta. If you simplify this, you're definitely gonna get your sine, okay? Then I'll regroup this and say if I have my cos, okay, of a 90 minus alpha, and then negative and negative, I'll have a plus theta. And then I'm gonna open this up using this identity that I was given. Okay, so I'll have the cos of 90 minus alpha, the cos of theta. Since I'm adding, I'll subtract. And then I'll have the cos, no, it's supposed to be a sine, okay, because the formula says sine. So the sine of 90 minus alpha multiplied by the sine of theta. So compound angles, cos of 90 minus, gonna give us a sine of alpha, that's a cos of theta. Minus sine of 90 minus, that's gonna be a cos of alpha, then the sine of theta. So this is basically what we have here. But remember we said this gives us the sine of alpha minus theta if you do reduce the complementary angles. So that is how we would have gone about with 5.2.1. The key part is this 90, okay? And then this bracket. If you can introduce the 90 and combine with the bracket, the rest is history. Hence, so otherwise, you'll evaluate this. Okay, so I found this a bit challenging, but one thing that I saw, since they said hence, it's just a tip of the iceberg to say that we have to use what we already have, okay? But we have a sine and a cos, then a cos and a sine. So if this is a 76 and this is a 14, how does 76 and 14 compare? When I plus the two, I see that they give me a 19. Same applies with the 44 and the 46. So what I'm going to do, I know that sine of 76 could be the same as a 90 minus a 14. Okay. Then when I look at the 46, it could be the same as a 90 minus 44. So if I'm to replace this, you don't have to show it, but I need to show people why we are using that. We're saying minus sine 14, and then it's going to be the sine of 90 minus 14. You could also use the cos aspect. You would also get the same thing. So this is going to give me the cos of 14, the sine of 44, minus the sine of 14, and then cos of 44. We said 90 minus 44. Does that make sense? Does that make sense? Yeah, it makes sense because 90 minus 44 gives us a 46. Perfect. So we have 14 and 44. Then what I'll do, I'll say is the sine. I'll say 44 minus 14. I'll presume that this is my theta and probably that's my alpha. Okay, or you can do it the other way around. Okay, so if I'm to look at the way the question was presented, the sine comes first and then the cos, meaning that the 44 is the alpha, then that is the theta. So 44 minus 14 gives me a sine of 30, and that becomes a half. I believe if somebody had switched them around, you are going to get a negative, a half. But I would go with a half as my final answer. Okay, then 5.3. Examiners were bored. Ne? Now they are bringing calculus again, intrigue. These guys. We have f of x as this, meaning that our f of x plus h is going to be the sine of x plus h. They want us to show that this, okay, show that this can be written also as that. Okay, let's give it a try. Do we need the limits? No, we're not going to use limits here. So we know that our f of x plus h, we've already said is the sine of x plus h. We are subtracting our f of x, which is the sine of x, and then we are dividing by h. So no limits whatsoever, né? Because it's not calculus. Then let's expand this using the compound angles of sine. So it's going to be the sine of x cos of h plus cos of x sine of h. We are subtracting the sine of x and then dividing it by h. Now we need to regroup because we are seeing some like terms. Okay, here and here we have some like terms. I'll say sine x cos h minus the sine of x plus cos x sine h. Everything is over h. Then what is common here is the sine x. Take it out. We are left with the cos of h minus 1. Okay, we are plussing it by the cos x sine h. Everything is over h. Which format did we have? Things were separated. Okay, split this since it's the same denominator. Gonna have the sine of x into cos h minus 1. Everything is over h plus this is gonna be cos x sine of h also over h. So all you have to do is just rewrite the way it was because we've already obtained whatever we are interested in. So that is cos h minus 1 over h, and then cos x, and then we have sine of h over h. Put the brackets the way they put them as well. So that is basically or technically how we would have gone about with this mini calculus kind of teaser. All right, then question number 6, which is also still under the trig. Okay, so they want us to simplify the following into a single trigonometric term without the use of a calculator. So what I can see, how many marks is it? 7 marks. Wow. These people are generous today, né? So we know that from our Cartesian, this is going to be a 360 plus, it's going to be a 180 minus, 180 plus, and then a 360 minus. Okay. So this 180 is going to be quadrant number 2. And in this quadrant, tan is negative. Let's reduce that. So negative tan x. And then 180 minus is still second quadrant. Cos is negative. So cos of x over 240. Which quadrant is 240? It's in the third quadrant, which is 180 plus. So that's the same as 180 plus a 60. Okay? Because 240 minus 180, you get a 60. And we know that in this quadrant, the cos is negative. So it's going to be the same as someone saying the negative cos of 60. And then when we look at this, what's going on there? We can change the tan squared into sine and say sine squared y over cos squared y minus 1 over cos squared y. Okay, beautiful. We move on. We're going to change now this tan into a sine and cos. So it's a negative sine x over cos x. Now multiplying it by the negative cos x. I would have killed the negatives. Negative cos 60 is going to be negative a half times. Denominators are the same. Okay, meaning that I can do the numerator sine squared y minus 1 over the cos squared y. Okay, then it's party time. Let's cancel out what we need to cancel. So this cancels that. And then what do I see? What do I see? So I can take this negative a half to the top because like 1 divided by 0.5 gives me a 2. Okay, so this is a negative and negative is a positive. So this negative is going to stay. So I'll have a negative 2 on top over my problem here. I have sine squared y minus 1. What I would do is take out the negative sign, and then I'll have 1 minus sine squared y, which also gives me the same as cos squared y. So I'll say that this top part is the same as negative cos squared y, and then I'm dividing it by cos squared y. So this cos squared cancels that cos squared, and then my answer is just a 2. Okay, someone will say we left out something. Yes, we left out the sine x here, which we cannot do. Okay, so 2 sine x becomes our final answer. All right, so that is how the 7 marks were meant to be obtained. So your reductions, you'll start earning marks just with the reductions. That's already 3. And then your magic here and whatever you do, you end up with a 7. All right, 6.2, prove this identity. Okay, prove the identity. We're being told that sine 3x over sine x cos x is equal to this. So let's start from the left-hand side because I have more elements there. So I know that sine 3x is going to be the sine of probably 2x plus x over sine x cos x. Let's expand the top using the compound angles. So it's going to be sine 2x cos x plus the sine x cos 2x. I'm dividing this by sine x cos x. What do we see on top? On the right-hand side, everything is just cos. So sine must disappear. So let's expand this double angle to sine x cos x. Then I'm going to multiply it with this cos x. Plus, let's change this to a cosine format. The double angle of cos is 2 cos squared minus 1. Okay, sine x into 2 cos squared of x minus 1. We're dividing this by the sine of x and the cos of x. All right, so what we see, let's take this out. I'm taking the sine x out. I have cos and cos, which is cos squared. So 2 cos squared of x is left. Then I also have this 2 cos squared. Does it make sense? It should make sense. Okay, so we're having 2 cos squared x, and then we are subtracting a 1. This is all over sine x cos x. So this cancels that. 2 cos squared gives me 4 cos squared of x minus 1 over the cos of x. So that is equal to the right-hand side. So that is how the proof would have been done. Alternatively, if you want to open this up, you can still go ahead. But I believe that would be a waste of time, because if you take this out, you'll be left with that bracket alone. All right, so that is the sweet 5 marks as well. 6.3. Yo, the devil himself, or the devil has softened. Determine the general solution. Okay, so this general solution was a bit tricky, guys. But the easiest way that I feel we can go about it is let's square both sides, because we need to get some single trig ratio that we can use. So I don't know how other people would have approached it, but for my case, I would have squared both sides. Okay, so that I have this squared and then that side squared. Okay, so if I open brackets here, I'll have the cos squared of x plus twice cos of x is equal to the sine squared x. I already have a cos x here, meaning that I can change this into a cos. So cos squared x plus 2 cos x is equal to 1 minus cos squared x. Let's transpose and take everything to the other side. There's something I left out. There's a 1 here, because when I'm opening, it's a cos squared plus 2 plus a 1. Good. Let's move everything to one side. Cos squared x plus 2 cos x, okay, plus a 1 minus a 1, and then plus cos squared x is equal to 0. Okay, then cancel out this and that. And then cos squared and cos squared gives me 2 cos squared x plus 2 cos x gives me a 0. What's common? Take out one cos. I'll be left with just a cos x plus a 1 is equal to 0. Okay, then we get into where people understand this better. So either 2 cos x is a 0 or cos x plus 1 is a 0. So meaning that here cos x is a 0. What's the reference angle? The shift cos of 0 gives me a 90. Okay, so I'll have x to be a 90 plus 360 times k. K is an element of integers. That is quadrant number, it's on the boundary between quadrant 1 and quadrant 2. The other angle or the other solution would be 270 plus 360 times k, because k is an element of integers, okay? So that is for the first reference value. Then with this one, we know that the cos of x is gonna be a -1. So x is gonna be the shift cos of -1, which gives me a 180, meaning that's gonna be 180 plus 360 times k. K is an element of integers. The other solution that I would have obtained is way above 360, which is like 540, because if I say cos of 540, I'll end up with a -1. But I don't need the 540 because it's way beyond the 360 point. So this can be left out and we focus on just those 3 solutions. All right, guys, that's how I would have nailed this question for 7 marks. Yeah, it's reasonable. Okay. Unlike the paper one where people is stingy, here, people are generous. They are just giving back to the community. They are trying to compensate for the disadvantage they were making. All right, in the diagram below, the graph f of x is negative cos 2x within this interval, okay? Now they want the period of f. Now we know that if the graph is just a cos x, the period is gonna be 360. If it's a cos 2x, it's gonna be 360 divided by 2, which is 180. Now, the other thing that you can also look at is how many cos graphs do we have? Because this is negative 180 and 180, which is basically 360. How many graphs do we see? We are seeing 2 graphs of cos, and each graph is taking an interval of 180. So that is the period. Then they want the range. Range is basically y values. We have -1 and +1. So we're going to say -1 is less or equal to y, less or equal to 1. Alternatively, y is an element. You use the square brackets, -1 and 1, because they are inclusive. 7.3, they want us to sketch, okay? So with the sketching, we're going to use our calculators, okay? The graph is tan of x minus 45, okay? We're just plotting one graph, so we don't have to use the other graph. Okay, the intervals are basically, the starting point is -180. The end point is +180. The step is 45. There we go. Okay, so -180, I'm getting a -1. Okay, -135 is a 0. Why don't I use a different color? Okay, so we said -1, that is a 0. And then -90 is a 1. -45 is a complex error, which is an asymptote. Okay, just in case the asymptote, just like that. Then 0 is -1. Okay, and then 45 is a 0. And then 90 is a 1. And then 135 is an error, okay, which is an asymptote as well. Then lastly, 180 is a negative. Is a negative what? Is a -1. Okay, so how do we plot this? So since it is moving towards the asymptote, we can just connect something like that. Okay, this one must move towards the asymptotes, just like that, and then towards also this asymptote. And then lastly, this one must just move in that direction, because if ever we were to have another graph or any other points, let's say we are using 45 now. So 180 plus 45, it's going to give us 225. And then the tan of 225 minus 45 was going to give us a 0 somewhere there, so that the graph just moves in this sort of direction. Okay, so this must move towards the asymptote. So guys, that is our graph that we can label as G. All right, then they're asking us for which values of x is f below, okay, the G of x, between -180 and 0. G is above, no, G is below. F, no. They said f of x is less than G, meaning that f needs to be below G. So where do we find the graph of f to be under G? So between this point and this point, the graph is below. So we're going to say -90 and then -45, okay? I don't know about this side, how the points, because I'm not that accurate with my drawing, but I'll presume they were using the same line and then they, okay? So where do we find f to be under? So I'll say negative 90 is less or equal to x, and then is less than 45. Reason as to why I cannot use the equal sign is because that's an asymptote. Okay, then 7.5, they want us to get the maximum of this entire thing. So the trick is just on the exponent. So if I rewrite this exponent, or if I take out the negative sign, I'll have 1 minus 2 sine squared of x. And 1 minus 2 sine is the same as cos 2x. So negative cos 2x. So what is the maximum of the cos 2x? That is what the question is asking for. Remember, initially, the graph was a negative cos 2x. So its maximum is a 1, okay? Meaning that where there is this graph, I'll just put exponent 1, and then my answer becomes F4. Okay, so that is question number 7. All right, we move on to question number 8. So question number 8, they are telling us that in the diagram below, A, B, C lie in the same horizontal plane. The vertical pole DC is H units and AB is K units. CAD is theta, and then BAD is beta. Okay, and then DBA is alpha. Now they want us to express CDA. CDA. In other words, this angle here in terms of theta. So we know this side as the opposite, and then this side as the hypotenuse. Determine the size of CDA, but we don't need to do that. They only want the size, this angle. So if that's a 90, this is a theta, meaning that this angle should be a 90 minus theta. That's why it's a 1 mark. Then if it is true that this is a 90 minus theta, the next question is asking us to determine the length of AD. Okay, determine AD. So this is our hypotenuse, like we said, this is the opposite to the theta. We can use the sign and say that the sine of theta is equal to the opposite, which is h, over the hypotenuse, which is AD. Do the cross multiplication, so AD becomes h over sine of theta. That's how we go about it. How many marks? Should be 2 marks. Okay, so we said AD is h over sine of theta. Then 8.3, can we show that CD can be written as that? Okay, prove that CD, which is the h, can be written as a k sine of something, sine alpha, sine theta over the sine of alpha plus beta. Okay, so we're looking at AD. Now, what I'm going to do is, if this angle here is alpha, this angle is a beta, it simply means that this angle here, okay, let's look at our BDA, is going to be 180 minus the alpha plus beta. Okay, so this is the angle BDA. Then I can use, because I already have my representation of h by 8.2, or the A, okay, and I can use the triangle BAD. Okay, from BAD, let's use the sine rule and say that AB over the sine of BDA should be equivalent to AD over the sine of DBA. Let's do the substitution and see. What's our AB? That's going to be a K over the sine of 180 minus alpha plus beta, okay, is equivalent to the AD over the sine of this alpha. Okay. Then let's do the cross multiplication and the substitution. Okay, let me just erase this so that I have more space. So we have the k over, when we reduce this, that's gonna give us the sine of alpha plus beta is equivalent to the AD, which we already have as h over sine theta. Now we are multiplying it by this as well, 1 over sine alpha. Then make h the subject, since we're looking for h. Okay. So cross multiply k over sine of alpha plus beta is equivalent to h over sine of theta, and then the sine of alpha. When you cross multiply, our h becomes what we were given. Okay, so that is how we would have gone about with proving that for the 5 marks. So sine rule, and then what is important is for us to get this angle first, and then apply what is next. All right, then 8.4, calculate the length of CD. Okay, what we know about CD is the h. In other words, we are trying to do the substitution back into the formula. They told us k, the sine of alpha, the sine of theta, over the sine of alpha plus beta. Is that correct? Yes. So we substitute. We're saying our k is a 95 multiplied by the sine of alpha, which is a 32,7, and then the sine of theta, 43,9, divided by the sine of alpha, 32,7, plus the 61. When you punch all of this into the calculator, I'm getting a 35,66 meters. I don't know. Somebody can advise us otherwise, but that's what I'm getting. All right, then let's get to question number 9. The paper is now just starting. We are just starting. Question number 9. In the diagram below, CD is a diameter with a center O. Okay, E is a point on the circle such that DE produced to G. Okay, we have other extensions, the OG, the CE, the CG, blah, 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 blah. This is X, and then they're telling us that this is a 90. Now pay attention. They told us it's a 90 COG, and then they never indicated it. So I'm indicating it there for myself. All right, then 9.1, they want us to prove that COC GE is a cyclic quad. Okay, so they want us to prove that this and that and this entire thing is a cyclic quad. So for us to prove cyclic quads, number 1, we have what we call the exterior angle. We have the opposite angles being supplementary, and then we have the angles in the same segment. So any of the 3 that we can see is what we can use. So number 1, what I can see or what I can notice is that O1 is a 90, we were told. Okay, O1 is a 90, that is given to us. If O1 is a 90, we know that DEC is also a 90 angle in a semicircle. So the whole of this is a 90 because this is a diameter. And if it's true, that is a 90, then CEG will also be a 90, this one. So since we have the 90 and the 90, in other words, we are getting the bow tie here. The bow tie is already out. So this is a 90, that is a 90. So that is enough to prove that the 2 or the shape is a cyclic quad. So therefore, OCGE is a cyclic quad. The reason we're gonna say the converse of angles in the same segment. Okay, so that is how we would get those 3 marks. And then name 3 other angles that are equal to x. I'll just write this up here because I don't want to scroll up and down. Okay, 9.2 angles that are equal to x. The first one, we have this one, C1. The reason, this is a radius, that's a radius. So angles that are opposite equal sides. Okay, so if C1 is x, remember we've just proved that this is a cyclic chord. So meaning that the bow tie will still hold, meaning that this G2 is also going to be x. Angles in the same segment or angles subtended by the same chord. Okay, if this is x, then we could also observe another x or another bow tie, just like that. Okay, so if this is x, meaning that even the G1 is also x, same story, angles in the same segment. All right, so we have G1 as x and then all of that. Okay, so that is how we would have answered that 9.2. 9.3, they want us to get the size of DOE. DOE. This is D, this is O, this is E. So they want us to get this angle here. Okay, let me just try to erase some things here. Okay, so how do we get this angle? Number one, we say that this was a 90. We did prove that because it's an angle in a semicircle. And then we have this as our x. But what is this angle here? It must be the same as this. Does it make sense? So we said angle D. Angle D. Okay, let me look at it in a different approach. Mustard. If I look at this big triangle, this is a 90. This is our x, meaning that this angle D is going to be a 90 minus x. That's what I'm going to start with. So I'm saying that D, this mustard is something else. Okay, 90 minus x, angles in which triangle? I'm looking at triangle DCE. Okay, then if this is a 90 minus x, this is a 90, then I need to find what O3 is. Remember they said DOE, if I'm not mistaken, okay, which is O3. Okay, so if it's a 90 minus x, then I can say this 90 minus x plus 90 plus O3 gives me 180. Okay, so a 90 minus x plus a 90 plus O3 should give us 180 interior angles of a triangle. So that's a 180, which is going to cancel out, meaning that O3 is going to be x. All right, so alternatively, there could have been another way of doing it, okay, which at this point, I'm not so sure, but that is how I would have gone about, okay? Let people give us any ideas of how they worked out 9.3, please. Question number 10. Okay, question number 10. In the diagram below, A, B, C, and D, E, F are drawn. So A is the same as D. Okay, perfect. B is the same as E, and then C is the same as F. Okay. Use the theorem or the diagram above to prove the theorem that states that if two triangles are equiangular, then their corresponding sides are also in proportion. So what we normally do is that start by constructing. Okay, just label this any letters of your choice. I'm gonna label it S and T. So step number 1, you have to tell us that construct the line ST, okay? Construct the line ST on the side AB and then AC such that, okay, such that the distance AS is the same as DE, and then the distance AT is the same as DF. That is what we need to start with, okay? So if construct to show that this is the same as that, and then this is the same as that. If that is correct, then we can go ahead to say that these two triangles are basically congruent because we have this side and that side, this side and this side, and then we have the angle. So therefore, I'm saying that AST is congruent to triangle DEF. Reason, side, angle, side. And if that is done, then we know that this angle E is going to be the same as, I can say this is my S1, this is my T1. Okay, I know E is the same as S1, which is the same as this angle here, B. And then consequently, we know that T1 is the same as that other angle that is F, which is the same as which angle? C. Then if that is correct, then it makes these angles to be corresponding. And if they are corresponding, which means that these lines are parallel. Okay, so we're going to say that therefore, our ST is parallel to the BC, the converse of corresponding angles. And if that is true, then we can use the midpoint theorem or the proportionality theorem, not necessarily midpoint proportionality. So they started with DE. Okay, DE is the small side over the bigger side. So I'm going to say that if I have my AS over AB, okay, so AS over AB should be the same as AT over AC, okay, over AC. But remember we said that our AS is the same as DE. So replace that and say last that DE over AB is the same as, we said AT is the same as DF. That is DF over AC. So that is how you do the proof for this particular question. 6 marks. All right. 10.2. 10.2, the diagram below, ACF are points on a semicircle with center B. A circle with center C is drawn. The radius of the semicircle is twice the radius of C, meaning that the radius of center B is the same as twice the radius of C. Let's leave it at this point. We're gonna need it probably somewhere. Then fade is a tangent to both circles respectively, and then that is a straight line. Then step number 1, prove that AFC, okay, this AFC, okay, prove that this triangle is similar to FEC, to this triangle here. Okay, so step number 1 that I'll do, I know that my F2, this is a 90 angle in a semicircle, eh? So F2 is a 90 angle in a semicircle. We know that E1 is also a 90, a tangent and radius, tan perpendicular to radius, meaning that F2 is the same as E1, which is 90. Okay, then 2, we can see that F3, this angle here, is the same as this angle here. So angle CAF is the same as F3. That is basically the tan chord theorem. And automatically this C1 and the C2 will be equal to each other. So C1 and C2 will be equal. Reason, the remaining angle of a triangle. So we have three fundamentals and you draw the conclusion. Therefore, AFC is similar to FEC. Reason, we said angle, angle, and then angle. Okay, so that is how we would obtain the 5 marks. Then 10.2.2. Okay, they're telling us if the radius of the smaller circle is P, determine the following in terms of P, the radius of FC. Let me do it here. So let me just try to redraw those two triangles somewhere here so that we see what we're talking about. Okay, we say this is A, F, C, that's our bigger triangle. And then the smaller triangle, we said it is E, C, and F. Remember, this was F3, and then this was a C1, but that is not important. Ne? All I need to know is that FC goes with EC for the small triangle. AC of the big one goes with FC of the small one. Then I can do the comparison, okay? So if I'm to compare this, remember our AC from here up to there. Remember the radius is twice. They told us that this is a P. So R of B is 2P. So if that is a 2P and this is a 2P, it becomes a 4P. And then this distance from C to E is what we are having as a P, meaning that I'll have this AC as my 4P, and then I'll have the EC as a P. Let me compare the sides. So I'll say that if I have AC divided by FC, it will be the same as someone getting FC divided by the EC. Reason is going to be similar triangles, or you can tell us that those two triangles are similar. What we can see, we can do the cross multiplication, meaning that our FC squared is equal to AC multiplied by EC. Then our FC squared, we know that our AC was 4P. Our EC is a P, meaning that we have a 4P squared. Then we can find the square root on either side, meaning that FC is just a 2P. All right. Then part B, they're telling us that they want the length of FD. Okay, they want the length of FD. If FE is the same as ED. If FD, they want the length of FD. If this distance is the same as that distance. Now, what we just calculated was the FC. Let me just erase this out. Okay, so we say that our FC is twice P. We have this radius as a P, and we say this is a 90, meaning that we can use our theorem of Pythagoras to find FE first. Okay, so we're gonna say that FC squared. Let me try to redraw that. Say that's a 90. Oh, so FC and E. FC and E, we say this is a P, and this is a 2P. So we're going to say that FC squared is the same as the CE squared plus FE squared. So 2P squared is equivalent to CE, which is a P squared, plus FE squared. So meaning that our FE alone is going to be the square root of 4P squared minus a P squared, which gives me a 3P squared, and a square root, which is the same as root 3 of P, okay? But that is just FE. They told us FE is the same as ED, okay? Meaning that our FD should be twice, okay? Multiply this by 2. So 2P square root of 3. That becomes my answer. Or someone can say 2 root 3 with a P. It's still the same thing. All right, question 11, the last one. In the diagram below, we have a cyclic quadrilateral EFGH. Okay. Then chords EH and FG are produced to meet at K. Okay. M is a point on F such that MG is parallel to EK. KG is the same as EF. Now they want us to prove this. 6 marks. Okay. So before we do the proof, this is a cyclic quad. EFGH is a cyclic quad. And if it's a cyclic quad, we know that H1, okay, if I call that X, it's going to be the same as F. Okay, reason being, let's just say it. H1 is the same as F. That is exterior angle of a cyclic quad. That's number one. Number two, the other thing we need to highlight before even we start the proving is that G1 is going to be the same as E. Also exterior angle of a cyclic quad. So if this is a Y, this must also be a Y. Now let's do the proving. So what I'm going to do to get this, I need to prove that triangle KEF is similar to KGH. Okay, so KGH, the same as KEF. So this small triangle and a bigger triangle, prove that they are similar. And then we shall be in position to do that. So what we're seeing is that both triangles are sharing a K. Okay, K is the same as K. Reason, it's common to both triangles. And then we're saying that G1 is the same as E. We saw that, say the exterior angle of a cyclic quad. And then lastly, we're saying that H1 is the same as F, same story, exterior angle of a cyclic quad. Okay, so we're saying that KGH is similar to KEF. And if that is the case, then we can do the comparison of the sides, meaning that our KG, okay, this KG here, the common angle and the Y, the common angle and the Y over KE, okay, is equivalent to GH. So I'm to look at GH, the Y and the X over the Y and the X, EF. So GH over EF. Okay, what was the question asking for? EF. But the question also told us that KG is the same as EF. So where there is KG, we can put an EF somewhere. So meaning that we have EF over KE is equivalent to GH over EF. Cross multiply, we have our EF squared is equivalent to GH multiplied by the KE. So I think that is what the question has, and then that is how we would have obtained the 6 marks. So start by proving these two triangles. Reason is going to be angle, angle, and then angle. All right, then 11.1.2, can we prove that KG squared is equal to EM dot or times KF? So what I can do here, remember it is, we have a set of parallel lines. I can use my proportionality. Okay, proportionality, because this line is parallel to that. So they said, what did they say? They said KG squared. Okay, so KG, so what I'm going to do, I'm going to look at the side, and which side am I gonna say? I'll say that if I get the KF, the whole of KF, over the KG, okay, should be the same as EF over EM, something like that. Okay, so I'm going to say KF over KG is equal to EF over EM. Reason, the proportionality theorem, because EK is parallel to GM. Then we can, what did they tell us? Sides that are the same, KG is the same as EF. EF is the same as kg. So let's change the EF into a kg, here to a kg. Mean that KF multiplied by EM is equal to kg times a kg. So meaning that KF times EM is equal to kg squared. That's what the question wanted using the proportionality theorem. And then 11.2. If the length of KE is 20, KF is 16, and GH is 4, calculate the length of EM. Now remember, the previous two questions gave us two formulas, okay? The first formula, or rather the last one, was kg squared is equal to KF times EM. And then the first one was telling us EF squared, okay? That if we have EF squared is the same as GH and KE, GH and KE. Now, what do the two have in common? EF is the same as KG, so either way. So what I'm gonna do, let me start by looking for the EF, okay? Since I have my GH, I have my KE. So meaning that EF squared is gonna be the 4 multiplied by 20, meaning that EF squared gives us 80. But we know, okay, that EF is the same as a kg from the first part, okay? Meaning that instead of me replacing or calculating this back, I'll just replace it with the 80 and say that 80 is the same as KF multiplied by EM. So what is my KF? My KF is 16. So 80 is equal to 16 times EM. Divide both sides by 16. Okay, so how many 16s are in 80? We only have 5. So EM becomes 5 units. All right, guys, so that brings us to the end of the paper. I hope you guys have scored much in this paper just to liberate yourselves from what paper 1 did, okay? So I wish you guys all the best, okay, as we compare the answers. And I once again appreciate you guys for your comments, for your subscriptions, and for your views. Keep it up, and I wish you all the best in the remaining examinations that you're writing.